Hello everyone and welcome back to the Leetcode grind. Today we have 1422 maximum score after splitting a string. It says here that we're given a string S which contain only zeros and ones. It's a string of only zeros and ones from which we are to return the maximum score where the calculation of that maximum score depends on splitting the string into two non-empty substrings on the left side and the right side, and both are non-empty. And the score after splitting a string is the number of zeros in the left. So on the left side, if it's a 0, then you score a point. If it's a 1, you don't score a point. But then plus the number of ones in the right substring. So for the right side to score a point, you actually have to be a 1. If it's a 0, you don't score a point. So if you look at this example here, the reason why the output is 3 is, first of all, it's non-empty. Both left and right cannot be empty, so at most we can only consider the right partition as everything minus at least one value for the left, which means there's 3 ones on the right, so those score points. The left can only score a point if it is a 0. If it's not a 0, you don't get a point. Okay, now looking at this example here, the reason why it's a 5 is when we get to a point where we consider these two as the left partition and these 3 as the right partition, then, well, we can score points because left side zeros count towards a point and the right side ones count towards a point. So here we would get 5. They qualify. Now if we were to reverse this, like for instance, let's say, we reverse it and say 1 1 0 0 0. What do you think would happen? Well, the left partition will be, actually this will be different because, actually let's go through this. Using the same logic, what was that? 1 1 0 0 0. Let's see what the expectation would be. 1 1 0 0 0. Now remember, you can only score a point on the left if it's a 0, and you can only score a point on the right if it's a 1, and at minimum, there has to be at least one value on the left and the right. So at minimum, we can count, there has to be at least one value on the left or the right. Okay, so let's go through this. Now, starting off, the left is not a 0, so no points there. And the right, on the other hand, has 1 1. So let's say we're starting here where this is left and this whole thing is the right. Yeah, there is 1 1. So our current potential maximum is that. Now what if we say, okay, now let's consider if this is left and this is right. Well, on the left side, now there's, well, still no zeros, so no points added there. But on the right side, there's no ones either, so no points added there. So that's now good. So let's just take the previous max, which is 1. And then if we say, okay, now at this point, we're here, this is left and this is right. And we can say, you know what, there's 1 0, so great, we can add 1 point for that. There's no ones on the right side, so no luck there, which means the potential total is 1. Best score still remains a 1. And then I think I see where this is going, but let's continue. Now this is the left side, let's say, and this is the right side. Well, remember, for the left, you can only count the zeros as scores. And we have 2 zeros, so now this is 2. On the right, there's no ones, so we don't get any score there. But look at that, because we have 2 zeros on the the left partition, our score is 2, which is the current max, and that's the winner. And we stop here because once again, we need at least one value on each side. It can be non-empty. And let's check our understanding and say, if we return 2, is that correct? Let's check that out. And case 4, yeah, 2 is correct. Okay, so why don't we implement our logic? What we did was we started with the count of ones. Remember to score a point. Now we're trying to get the best score, and we'll start that at 0. And then for the left to count, it has to be zeros. So let's say just left, but this is the zeros. And then the right is going to be the number of ones on the right side, and we will count all the ones in the entire string because we're going to do something, and that will come up. We'll say as count of 1, and this obviously is number of ones. So number of zeros and the number of ones. Okay. Now, the way we'll handle ignoring at least the first character is by saying, and the best cannot be negative, so we can set that as the starting point and say, for every character in the string, if the current character is a 1, will decrement the right count, right? So we don't have to worry that, hey, but you know, the right side cannot include the whole thing. It can at most include everything minus at least 1 on the left. No problem, because we're going to handle that by checking that condition first. If that current char, starting from the first char and just handling every char, if that first char is a 1, we're going to say, let's remove the count from the right. So we'll just handle that. Now, because this string is guaranteed to be just zeros and ones, we can straight up go to the else condition and say, if it's not a 1, then it has to be a 0. And you know what? If it's a 0, then we get to count that towards our score. So we can say left is plus equal 1. And at that point, we did our calculation. At this point, we have this row here where we have the current calculation, and say current score is going to be left plus right, whatever we have ongoing, and then the best score will be the max of either what the best is, which starts at 0, or the sum of left zeros and left zeros and right ones. So we can just remove this line and then make sure to return the best score. Let's give that a go. And that did not work. We have 3. Why do we have 3? Best is the maximum of left plus right. Oh, because we are counting the last one. So what's happening here is, because we're counting every character in the string, we also go here and say, if that's not a 1, I mean, if it is a 1, then we decrement right. That's not the case for this guy, but it is a 0, so we're actually incrementing it by 1, and we don't want to do that. So let's say we care about the string up until the last one, and that should work. Yep. So because both sides, left and right, have to be non-empty, we don't want to count the last one. And we can submit. And there you have it. This was once again 1422 maximum score after splitting a string. Thanks so much. Happy coding, and see you next time.